Welcome to this Edsim++ instruction video called General Operations. My name is Nico Punt and I'm going to show you today the most common actions you can perform within the Edsim++ graphical user interface. So let's start by adding a compartment object onto the desktop. You do this by clicking on the template and keeping your left mouse button pressed, and by then dragging the object onto the desktop. And you see this object is then automatically selected. If I click somewhere on the desktop, it will be deselected. In the moment I select an object, you see those special action handles appear. And I can use that to perform operations on the object. For instance, if I want to move the object, I click on the central handle. Note how the cursor changes its shape. I click the left mouse button and I start dragging the object. If I do this with one of the outer handles, the object will be resized like this. A selected object can be easily duplicated by clicking the duplicate button. If you want to select more than one object, simply draw a box around it, and then I can, for instance, delete all these objects by clicking the delete button. Okay, now let's create a simple model. I add a compartment, an input, an output, and now I'm going to add another compartment. Note how this other second compartment is of a different type. It's a peripheral compartment. This is because Edsim++ knows that most models should only have one central compartment. And in the moment you add another compartment, Edsim will automatically change it into a peripheral compartment. Alright, let's connect these objects. In order to make a connection, you click on the source object, you press the left mouse button and start dragging towards the target object. When you're on top of the target object, you release the mouse button and you have the connection. It's very important to discriminate between the source and the target object. For instance, if I want to connect the elimination object to this compartment object in this way, it will not work, because the compartment object must be the source and the elimination object must be the target. So we must connect it like this. And the same is true for the peripheral compartment. I cannot connect it like this, but I can connect it like this. Now what you also see here is that this connection between the central compartment and the peripheral compartment is a bidirectional connection. This can be seen because you have two arrows on either side of the connection. This means that material can flow from the central compartment to the peripheral compartment and vice versa. One of the great features of Edsim++ is that if you put objects on the desktop, they have smart default values. So in the moment you are ready creating a model, you can also directly simulate it. And I can show you this by clicking on the Run button now, on the Simulate button. And you will be presented with a nice chart, in this case showing the concentration in the central compartment, and here the concentration in the peripheral compartment. I can easily change the type of an object by selecting it, and if I, for instance, I want to change this from an injection to an absorption. And I can also change the name of an object by clicking on this text box here, and then, for instance, I want to rename this input object to tablet. Now if I simulate again, you now get a nice oral absorption profile. Apart from a chart, you can also have a look at the raw numbers. If I click here on output, you are presented with a table in which these curves are displayed as numbers, and you can copy these series to any other program, like drawing programs or Excel or whatever. In fact, what you see here is a Excel compatible spreadsheet, so you can do things like entering formulas like this. And many more things you can also do in Excel. Okay, let's go back to the chart. Apart from showing this combined chart where all the curves are combined in one view, Edsim has another very interesting option, and that is to show the curves in the objects they belong to. And you can activate this feature by clicking on the mini charts button right here. And now you see the curves in the objects they belong to. And if you think, okay, this is a bit small, you can click the right mouse button and a loop will appear. And I can now move over the objects to have a better look. You can also zoom in or zoom out, or make the model fit the available window space with clicking the zoom to fit button. And if I even would zoom in further by this manual zoom, I can then pan through the model by using the scroll bars. You can undo all zoom operations by clicking the cancel zoom option. Now if I double click an object, the object properties windows will appear. So I will double click here on the tablet, and you see here the properties window coming up. And it is divided in a number of sub-type properties, and here we are at the object level. And what I can do here is let's change the color of an object. So I click here on the color button, and I can make it, for instance, yellow. What I can also do here is add the dose to the dosing schedule. So if I want to add, for instance, 150 milligrams after 100 hours, and I will do that with an interval time of 12 hours, and I give 5 dosages, and I do a simulation, you see it's directly displayed in the mini charts, this update. Of course, the main chart is also updated. The next step here is variables. And if I click here on the central compartment, I can here specify an initial value for a variable. But more importantly, I can also state if it want to observe this or not. So if I select, for instance, here the concentration, and I do a simulation again, you see it's not visible anymore, the curve, the concentration in the central compartment. So I enable it again, and I also enable the free concentration. Start a simulation again. Okay, you see one curve, but I will explain this to you later. The next step is the parameter step. And here you have the parameters that belong to the selected object. Now if I click on this peripheral compartment, I have the rate constant parameters for the incoming material flow and the outgoing material flow. Now if I change this, for instance, to 1 per hour, so the distribution rate constant for the backwards transport, and I do a simulation again, you can directly see how the profile changes. Okay, let's go to the constants. So here are listed the constants that belong to a particular object. And now I will select the central compartment, and I will change the value for the fraction unbound to 0.5. I do a simulation again, and now you see a second curve coming up here, which is in fact the free concentration in the central compartment. Let's move on to the next step. What we see here are the options that can be set for an object. And for instance, if I click here on elimination, you see that we have here a mode option, and the mode option is set to rate. And this means if I look to on the parameters tab, that here you can see a elimination rate constant. Now if I go back to the options tab again and I change this to clearance and then look at the parameters again, you see that I have a clearance parameter. So you can easily switch between rate constants and clearance, rate parameters and clearance parameters. The next tab I'm going to show you is the simulation tab. And one of the important fields here is duration. And if the value for duration is set to 0, Edsim automatically determines what the correct simulation time should be. And it simply uses the events that occur in the model for automatically determining the simulation duration. So it knows how many dosages I give and what the interval time is, so Edsim can then automatically determine how long the simulation should be. But of course I can override this. I can enter a large value here, for instance 200 hours, and I simulate again. Okay, maybe more. Let's make it 300 hours. And I simulate again. And you see this shifting up. If I look at the big chart, you see we're going up to 300 hours. Okay, I will make it 0 again, so we have a better view. And let's go to the final tab. It's the application tab. And here I can do all kinds of things. I can change the appearance of the charts. For instance, I can add grid lines, for instance, only to the x-axis. If I look and I do a simulation and I look here, I see here the grid lines on the x-axis. And if I click the y-axis, and if I look again, you directly see the grid lines for the y-axis. I can also change the scale. I can change the log scale, typically for the y-axis. But you can even change it for the x-axis. Okay. Okay, let me reset all this. Have a look. What I can also do is explicitly set the x variable and the y variable. So if it is not entered, it means that the x variable will always be the simulation time, and the y variable will be all observed variables. But I can limit this. Okay, I can say here, okay, I want to have here the simulation time, and here I only want to have the concentration in compartment 1. And if I do a simulation, you see that I only see here only the concentration in compartment 1. But what I also can do is I can use something else for the x variable. For instance, I use here the concentration in compartment 1, and here the concentration in compartment 2. And if I then do a simulation, and I look here, you get this kind of hysteresis profiles. Okay, let me restore the settings again. Alright. So if you want to save a model, you can click here on the File menu and select Save Model or Save As Model. And you can enter a file name. You can do the same by clicking on the Save button. If you want to open a model, you click on the File menu, click Open Model, and select a model. Or you click on the Open Model button. You can also save a model in a different format. I'm going to show you, for instance, the Excel format. And I give it a name here, Test, and I save it. And Excel is started immediately. And you can see here a picture of the model. You can see the charts. And you can see the output values where you can calculate, make extra calculations with. So very, very flexible. I close Excel again. What I can also do is, when I'm here in the Model tab, I can copy a picture of the model to the clipboard. So I click here, copy, and now I start Microsoft Word, and I simply do paste, and I have the picture right here. Okay, let's close this again. Okay, let's create a new two-compartment system from scratch. So I clear the model. You can do this with File, New, Model, or click on this Create New Model diagram button. I add an input, I add a compartment and an output. I add a second compartment, I make the connections. And I can do a simulation. And it appears, because this is still on, it appears in the compartment itself. But I leave it on because I like it very much. Now, if I'm going to look at the results, and I look in the Symbols tab, you have an overview of all variable values at the end of the simulation, parameter values and constant values. Now, having default values is a very handy thing, because you can always do a simulation. But it can also be very tricky, because you don't know which values you actually entered. And we have a feature that will help you in checking this. For instance, if I click here on the elimination and I change the parameter, for instance, I double the elimination rate and I click Simulate, and I look at results and I look at the Symbols tab, you can see that all symbols that are non-default, that are changed by me, are marked yellow with a yellow color. So you have a very quick and nice overview which parameters you actually changed. Now, what I can also do is copy a complete model. So if I select this model, all objects are selected, and I click here Duplicate, I get a complete copy of the model. And I can use this to play what-if games. What I can do here, for instance, is if I double-click on the input, I say, okay, I'm going to give, for instance, 1200 milligrams in 16 hours. And I give 5 dosages. And I can do run a simulation. So what I can do is I can directly compare the effect of a change in one of the dosing schedules or one of the parameters. And I can also see it in the overview. Okay, so let's delete the second model here. about this elimination object. We could say this is only a renal elimination object. And then I could add another elimination object connected to the central compartment and say, okay, this is a metabolic elimination object. And if I simulate this, you directly see the effect that it's even steeper, these curves. Elimination is faster. But I can even further, I want to know for the metabolic elimination which metabolic pathways are available. So what I can do is I add a transport object and I call it, and I make it a different type, metabolism. I can duplicate this. I need a compartment to collect the metabolites, so I duplicate this compartment and I do this again. It's right there. And I can make the connections. And if I click here and look at the parameters, as this FM parameter, I can specify what the contribution is of this metabolic pathway to the overall metabolic elimination. So I can say here, for instance, this is 60% and this pathway is 30%. So if I do a simulation again, you see here the metabolites forming. You can also make your model visually more attractive by attaching a graph to it. For instance, the injection here. I can create a syringe image for it. Make it a little bit larger. The peripheral compartment could, for instance, represent the brain. And this elimination route, as we said, is the renal elimination. And this elimination route is elimination through the liver, metabolic elimination. And the different metabolites we could represent using their structure formulas. So this way of making a model more attractive is of course very interesting for educational purposes. So this concludes the video general operations.